Good day, everyone. So, welcome to Vet Micro 515 for Veterinary Epidemiology. So, I'm Dr. Clyden B. Tenorio, and I will be your lecturer for this course this semester. So, for Vet Micro 515, these are the topics that we will be discussing this semester. So, of course, we'll start with the introduction to vet epidemiology. The following weeks, we will go to measure of health, measure of association, causality, the science of veterinary epidemiological research, sampling, and that will be the coverage of your midterms. Then after the midterm, we'll go with errors epidemiologic study. So I just put it here that perhaps you can schedule your mental health or reading break here. Let's see if you will be able to pursue that. Then we'll go to diagnostic tests. Then we'll delve into intro to veterinary surveillance, risk analysis, outbreak investigation, control of animal diseases. Then, lastly, we will go to appraising veterinary literature and evidence-based veterinary practice. Then, of course, you will have your final examination at the end of the semester. So for the grading system, I know that you are quite familiar with this one already. So of course, for the total grade, 33% of that will be from your midterm, and 67 will be from your final term. And of course, because this course does not have a laboratory component, um, this is the grading system that I'll be using. So we have your quizzes, 20%, your 1 hour exam is 30, and your midterm or final exam 50. So basically, it's the same for the midterm and the final term. And for the, of course, for the passing rate, you must get at least 75% overall for you to pass this course. So we have to impose the 75% passing rate of the College of Veterinary Medicine. So now let's go to what really is. Let's discuss what really is epidemiology. So this topic perhaps is very important with the emergence of certain infectious diseases such as COVID-19 and ASF, AI. So there is an importance that you, as veterinary students, should understand the principles, or at least be knowledgeable of the fundamentals of veterinary epidemiology. So what is epidemiology? So it came from actually Greek, from the Greek. So the term epidemiology comes from three epi, demos, and logos. So epi meaning upon, demos meaning village or people, and logos of course study of. So to translate that into modern English, studying something that is happening upon the people. Hence, the modern definition of epidemiology is that it is the science that deals with the occurrence and distribution of disease or health phenomenon within a given population. So be reminded, or at least be informed, that in epidemiology, we do not, especially in veterinary epidemiology, we do not just measure diseases or others. It could also be production parameters. So diseases and or health phenomenon. So with regards to veterinary epidemiology, these are the important facets that you must learn or at least be knowledgeable of in the practice of veterinary medicine. So of course, as previously mentioned, it is the study of disease or health phenomena in a population. So of course, it involves surveillance, measures of disease to your prevalence, incidence, and others, epidemiologic studies, so we will go through them. Specimen diagnostics, very important. Sampling for your measure of disease control, outbreak investigation, disease patterns, and association and causation. So if you can remember, most of these, if not all of these, are actually part of our topics to be discussed this semester. So I hope we will be able to go through them and you may be able to learn a lot from them. So what really is the importance or the purpose of epidemiology? So the field is important specifically for us veterinarians because it enables us to study what, who, or which, where, when, and why disease occur. That is very, of course, needless to say, that is very important. Number two, monitoring and surveillance of diseases and exposures. Again, very important. Identify and control disease epidemics. In the veterinary side of things, I already can think of ASF and AI that we need to identify and control, right? And lastly, we need to study risks that are associated with exposures. This is very important also with regards to all of this, all of the previous purposes, because when we are able to identify risks that are associated with exposures, we may be able to plot, or we may be able to develop control programs that will of course control the diseases and prevent it from occurring again. So within the realms of veterinary medicine, epidemiology is very, very important. Now, before we move forward, it is important perhaps for us to identify or at least define who is an epidemiologist. So we, and I know some of you in the future might be, we epidemiologists, we attempt to characterize individuals, be it humans or animals, with a high and low level of disease. Again, we need to check who has the disease and who doesn't. And yeah, number two, we need to ask questions that help to uncover factors that influence the risk of disease. So, who among the individuals in the population are most likely to have the disease? What are they doing? Why are they the most at risk? So we need to ask those questions. And if we are able to characterize the level of disease, what are the factors associated with the occurrence of the disease, we may be able to plot or identify or plan measures that reduce exposure to such factors and yung mga risk factors for us to limit the occurrence of disease and therefore control the disease. Now, when we compare the two, the epidemiologists with the clinical practitioners, we can say that epidemiologists are population doctors because we look, again, the definition of epidemiology is we look at diseases and health phenomenon in a target or in a given population, where in contrast to clinical practitioners, they may practice on one patient at a time. Now, in the previous slide, I have made the difference between population doctors, epidemiologists being population doctors in contrast to those who are clinical practitioners or are clinical doctors. So, there are difference in the clinical and epidemiological approach. So first, in the clinical approach, a veterinarian may be seeing one patient at a time. So they diagnose, test, and treat cases or illnesses in such patients. And of course, they may come up with a set of diseases that may be the cause of the case of the illness of the case. And of course, that is your differential diagnosis. And you can rule out as you do your test, as you do your clinical pathology and other tests, you can rule out from the differential diagnosis your final diagnosis and treat it accordingly. Now, in contrast to epidemiological approach, we approach illnesses, diseases, and health phenomenon, production losses, etc. in a population or herd approach. So we study differences in disease occurrence among different groups being that it may be different populations or it may be different subsets of groups within the same population. We identify risk factors. So risk factors, these are characteristics of certain individuals, of certain groups that make them more prone to disease. So we need to identify that. And in the epidemiological sense, we are not dependent on precise diagnosis. Rather, let me make a clarification on this. Yes, diagnosis is important for us to identify the cause of the health phenomenon, but what is important to us is that we are able to control and eradicate or eliminate the illness and prevent it from occurring again. So, precise diagnosis can be done together in tandem with our control and elimination efforts. So I hope that is very that has been the difference between clinical and epidemiological approach has been defined clearly to you at this point, because this is very important in vetmed, because the yellow line that splits the two does not actually sometimes doesn't exist in veterinary medicine. Why is that? Because we have veterinary colleagues that are let's say, working in poultry farms or in livestock medicine, wherein they enact population medicine. Imagine, imagine a veterinarian working in a poultry farm. Let's say there is 200,000 heads, and he or she or they do clinical approach. Good luck with that. So we in the veterinary medicine is we are actually in the subliminal part of this clinical versus epidemiological approach. Hence, again, this perhaps emphasizes that epidemiology is actually important in the practice of veterinary medicine, whether you go in clinical or you go in clinical small animal practice or in clinical livestock or poultry medicine. Now, in veterinary epidemiology or in epidemiology in general, we actually believe in two premises or two notions, perhaps. So the first is that disease or a health or production phenomenon is a result of a complex interaction between the agent, the host, and the environment. So in epidemiology, the interaction between the three, we can actually call them the interaction between the epidemiologic triad. So between the agent, the disease-causing agent, the host, and the environment. So, in line with that, do not be surprised when certain epidemics or when certain diseases blows up in certain areas in the country, in the world, such as for example, ito, nagka-AI before, I think it occurred before I left around March or yeah, early March 2022 that AI is was declared in Tacoma City. Now, if we put it through the lens of the epidemiologic triad, AI did not occur because simply the virus was present in Tacloban City. I do not think so. It perhaps my premise or my if we put it within the lens of the interaction between the epidemiologic triad, I suppose that the agent, the AI virus, was actually introduced perhaps through the migratory birds that are frequent in the Baras Bird Sanctuary. Perhaps. The environment played a role that because biosecurity in our farms, backyard or backyard or commercial, perhaps was not very strict, or in the area itself, the city, the province, the biosecurity protocols are not that strict that enabled the rapid spread of the virus. And of course, in the host factor, we do not usually vaccinate our poultry against avian influenza. I do not think there is currently a vaccine for AI. So weak immunity of the host, making them susceptible to the agent, with the environment being conducive to the spread of the agent. So perhaps that interaction actually is the reason why AI occurred in Tacloban City. Again, the disclosure, this is just my um, intuition based on the premise that disease and other production phenomenon is due to the interaction of the agent, the environment, and the host. Now, there are certain factors between the epidemiologic triad or factors or the characteristics of each of the three, the agent, the host, environment, that influence the disease potential or disease occurrence. So perhaps in the agent, environmental survival, antigenic stability, immunogenicity, virulence, pathogenicity, infectivity are characteristics of the agent, which is actually when we put it in the lens of AI, it very fit these characteristics are very fitting for avian influenza. Now, with regards to the host, it could be that the species is susceptible. So poultry again is susceptible to AI, of course. Age, sex, breed, conformation, genotype, nutritional status, physiologic condition, pathologic status. So these are some just of the characteristic of hosts that may or may not influence the occurrence of disease in them. We also have, of course, the third leg of the triad, which is the environment. So it could be the weather, it could be the housing, the geography, the geology, the management. As we discussed, biosecurity may have been lax. That's why AI occurred. Noise, air quality, food, chemicals. So anything that is not part of the host or not part of the agent would be put in the environment. So this just basically proves that any disease phenomenon or health phenomenon you can actually trace it back between the characteristics, if you can actually characterize it rather between the three legs of the epidemiologic triad. Now, the second premise, working on what we have discussed on the first premise, the second premise is that disease or health phenomenon or production phenomenon with regards to VetMed does not only occur or does not occur in random fashion. So remember your epidemiologic triad. So every time there is an infectious disease or any disease at that is kumakalat, animal or human disease na kumakalat, remember your epidemiologic triad. Now, for example, another examples again, very sikat, is the African swine fever outbreak that occurred in the Philippines. So take note, this is a snippet from CNN Philippines that occurred, nakuha pa natin, di ba, ASF occurred in us, in the country in mid-2019, if I remember it correctly. Then it spread like wildfire throughout Luzon. Then it found its way to Mindanao in the through the Davao region and kumalat na din throughout the different parts that were infected. Now, did ASF occur because ASF was present initially in the country? A lot of experts do not think so, because I think the consensus here is that it was introduced through the import of pork products or pork meat, pork products. So perhaps some of those pork that were introduced in the country were actually infected by the ASF virus. So if you put it here, if you ibangga natin siya sa what is known as a transmission pathway of the ASF, dito na tayo. It was introduced to our local domestic stock. And perhaps it might have spread through, again, materials or fomites, direct contact to other pigs that are infected or feeds that were infected. Again, stool feeding is an important transmission pathway. So if you can see, ibanggaan nyo itong second premise na ito together with the epidemiologic triad, you can clearly see that disease occurrences, infectious or otherwise, does not occur in just random fashion. Hindi lang yan siya nangyari kasi andyan siya. So there is always a reason and there is always a pattern. As previously mentioned, there is always a pattern. Now, epidemiological investigations actually are conducted for epidemiologists and for, of course, the general public for us to recognize these patterns. It is important that we recognize these patterns, these certain disease patterns, because it allows for the prediction of future occurrences and allows us to understand what may have caused it, what are the factors associated with it, to understand causation. So bakit siya nangyari? And of course, it's not only that we need to understand bakit siya nangyari, but we need to develop control. If an outbreak occurs, we need to control it, and of course, we need to develop plans for it to not happen again, we need to prevent it in the future. Now, this is and the illustration here, the figure here, shows the epidemiologic pattern of COVID-19 in the Philippines. So if you can remember, 2 years in already, we're in 2022, it actually started in early March 2020, around 2 years ago. So if you can see here, of course, in the initial phases, we had a very low number of cases until such time na there was it spiked. It spiked. We put control. That's why it's plateaued here. It spiked again. We tried to control, kaya bumaba. Nung bumaba na ang cases, nagluwag na naman tayo ng mga restrictions. That's why it spiked again. Then we implement strict control measures. it has gone down, then biglang nag-spike again, and it's not down. So basically, my point here is that we can actually track the occurrence of the disease and see what is happening if we are able to recognize the pattern. And at the same time, we are able to develop control and prevention efforts if we are able to, again, recognize and pay attention to the pattern of disease. So for us to understand, recognize, and use the diseases pattern, we need to ask the 5 W's and the 1 H of epidemiology. So who, which. So sino ang may sakit? Who gets the condition? Sino or anong animal or anong groups na animal ang nagkakasakit? Kailan sila nagkakasakit? When? Where? Saan nangyari ang condition? What? Ano ang condition? To begin with, how? Paano ba kumalat ang sakit? Or paano nakuha nitong certain individual, certain species of animal, certain groups of people or animals, paano nila nakuha ang sakit at paano siya kumakalat? And most importantly, bakit nangyari yung outbreak? So, these are important questions that will help us in understanding the said pattern of disease. Now, if we use those important questions laid out in the previous slide, we can actually divide the field of epidemiology into two. You have your descriptive and analytical epidemiology. As the name implies, of course, descriptive epidemiology aims to describe the occurrence of the disease or the health phenomenon in the population. So again, who, which, sino, ano ang nagkasakit, what is the disease, when, kailan, where, saan, and how much. Gaano karami ang may sakit at gaano karami ang walang sakit. Now, with regards to analytical epidemiology, it involves the analysis already of data that were gathered from descriptive epidemiology for us to test the hypothesis na nade-develop natin sa descriptive epidemiology. Because with regards to here, we're just basically describing the occurrence of disease. Now, with regards to analytical epidemiology, here we test kung totoo ba that there are certain groups, for example, there are certain groups that are more likely to have the disease. And gaano ba that likelihood, how much is that likelihood? So analysis is the analysis of the data gathered from descriptive epidemiology is actually the main role of analytical epidemiology. So it aims to answer why. Bakit there are certain groups that are more likely to have the disease? And why does the other groups do not have the same likelihood? How? What are the factors that have led to the spread of the disease? And how did it spread? It may explain how did it spread. So with regards to the two and including within the bigger picture of epidemiology, it may be analyzed that the descriptive is a step towards the analytic. So of course, when a disease problem occur, you need to describe. So we need to develop your case definition. Sino ang may sakit? Ano ang definition mo na may sakit? May sakit nga ba talaga? So you need to classify and count sino yung mga sakit, etc. With regards to analytic epidemiology, now you are talking of association and causation. So what are these risk factors na associated with the occurrence of the disease problem? So we have your conditional studies, intervention studies, etc. We'll go through these in the future part of the course. Now, of course, the end point and the end goal of descriptive and analytic epidemiology is, of course, disease management. We need using the data gathered from descriptive and epidemiology, analyzing analytical epidemiology, we must be able to develop plans to enable the control and prevention of such diseases. So, within the bigger picture of epidemiology, the two fields or the two subdivisions together with the control, prevention, risk factor analysis, etc. are actually linked together. So as previously mentioned, between the two, between descriptive and analytic or analytical epidemiology, descriptive, the main goal of descriptive epidem is actually to define, to characterize, and of course describe the occurrence of disease. So only one group is studied. So for example, the population at risk. You need to, the goal here is just again to describe what is occurring, what is the health phenomenon, why, where, when, na, who are affected. So yung mga questions kanina, and the goal, one of the goals of descriptive epidemiology is to end up with a hypothesis using the data that you gathered, or your data you gathered and you analyzed in the descriptive analytical, in descriptive epidemiology rather. Now, when we connect it to analytical epidemiology, the testing of this hypothesis actually occurs in, excuse me, analytical epidemiology, wherein we are able to compare at least two groups in comparison. So for example, we are not only studying those that who are at risk, but we may also compare those that are not at risk or those who are not exposed to see if yung hypothesis natin na na-develop na baka ito ang reason, if it is the reason, then perhaps it's most likely to occur in those at risk, and disease might not occur at those who are not at risk to the comparison group. So the end goal of analytic epidemiology is to have the hypothesis developed in the descriptive epidemiology, have it tested, and confirm whether we reject or accept the hypothesis, and use the hypothesis that is accepted or rejected in developing control and prevention programs. So I hope that clarifies the descriptive and analytic epidemiology. Now, let's delve deeper into descriptive epidemiology. So as previously mentioned kanina, there is always a pattern in the occurrence of disease. So it is the recognition of this pattern that is important. So again, back to the basic questions, who or which animals are affected. So it is a function of individual, herd, or the population. When do cases occur? So of course it's a function of time. Then where do cases, of course, place or geographical distribution or place. Then how much cases are there? So it's a measure of occurrence. Again, our next lesson, which perhaps will involve your prevalence and your incidence, etc., and other measures of occurrence or disease. So an important facet of descriptive epidem is for us to characterize the disease phenomenon or health phenomenon with regards irrespective of the individuals, the place, and the time. So individual factors, we must perhaps identify what types of individuals tend to develop disease and who tends to be spared. So characterize who are at risk and who are not. Spatial distribution, where does the disease occur? What is different about these places? What environmental factors perhaps are present in these specific places where the disease is occurring? So you need to ask again. Then of course, time or temporal factors, and how does the disease frequency change over time? Does it like this? Is it like dengue that only occurs perhaps during the rainy season, wherein breeding, or rainy season in the liminal period between rainy and summer or rainy season, wherein the breeding of mosquitoes are hastened or is developing faster, occurring faster. So what other factors associated with this change? So is it factor of the individuals, factor within the area wherein the individuals and the disease is occurring, or is there changes as time progresses? So these are important facets that need to be answered. So let's go through each of them. So first we'll discuss the individual or the herd level. So again, an important key point here is that we need to define who are the population or the individuals at risk. So these are those who are susceptible to the disease with some likelihood of exposure. So they are susceptible to the disease and they may have been exposed to the agent or exposed to the factor that causes the disease. So it may be that it is an animal level characteristics such as the species, the sex, the age, the breed, weight, etc. It could be a management unit or the unit of management level. So in the pen, the pond, the cage, the mob, the paddock. So size, soil type, stocking density, stage of production, pasture size, etc. are included there. It could be a farm characteristic, so location could be a factor. Um, yeah, source of stock, the price, etc. Village, locality, or district region. So there are different unit of study with regards to characterizing the population at risk. So for example, we have determinants of disease. So it could be intrinsic. When you say intrinsic, so it is the characteristic of the animal or the individual itself. So with regards to specific diseases, for example, cattle are more prone to foot and mouth disease than sheep and goat. So that's a species determinant. The species of the cattle is a determinant for getting FMD. They are more likely to get FMD. And with regards to sex, of course, dystocia, stillbirth, reproductive problems sa sow, are more likely or is only occurring on female. You do not hear stillborn or dystocia sa male or sa boar because they are not the ones carrying um, they're not the ones giving birth to the piglets, right? So alam nga naman you expect that the boar will have dystocia. Di ba you do not you do not expect that kasi wala naman silang female reproductive tract, right? So these are characters. The point here being is that we have intrinsic determinants of disease wherein these are specific characteristics of the animal, innate characteristics of the animal that make them more prone to certain health conditions. In contrast, we also have extrinsic. So these are characteristics that are not innate to the animal. So for example, we have Johne's disease, so Mycobacterium avium paratuberculosis or paratuberculosis. These occur more frequently in dairy than beef cattle. So the factor here being is the production method that the animal is subjected to. That is more prone to the spread of Johne's disease or paratuberculosis. Another example is avian influenza. It spreads easily, excuse me, hindi na makita, but it spreads easily in intensively reared poultry kasi nga stocking density is very very high, and of course when animals are very close to each other, such is the case when stocking density is high, spread of infectious diseases, i.e. avian influenza, is very very rapid. So these are factors that influence the occurrence of disease but are not innate to the animal. So extrinsic determinants of disease. Now, let's go to time or the temporal pattern of disease. So, ito na mga demics. You've heard the pandemics. Pandemics have been the catchphrase rather, of the 2 years that we have been under COVID. So let's go to them what do they really mean. So sa madaling sabi, when a disease is endemic or enzootic is another term kasi we use enzootic in animal diseases. So nga. So endemic or enzootic, the disease is usually frequent or in constant presence in a specific area. So for example, Cotabato province is endemic for schistosomiasis, endemic for fasciolosis, endemic for other animal diseases that they're just there. The occurrence may fluctuate, but they are there constant. Now, in contrast, we have epidemics. So these are disease that occurrence that is higher than expected. So for example, an AI outbreak the AI outbreak that occurred in Tacurong City, we do not expect or that AI will occur in Tacurong City because it's not endemic there. So that is an epizootic. That's an example of an epizootic. When ASF broke out in Kabakan in around early March this year, we do not expect that ASF will be there because ASF is not endemic in Kabakan. So, an outbreak occurred, an epizootic or an epidemic occurred, right? So, I hope that's clear. A pandemic naman, of course, COVID-19 is a pandemic. So, these are epidemics that are widespread in nature. So, perhaps it occurred around the world. Pan, meaning almost all. So it's a widespread epidemic. Basically, epidemics that are widespread. Now, in contrast, we have sporadic. So these are single cases or cluster of cases which are not normally present in an area. Examples of which is the supposedly in the early stages of monkeypox, sporadic cases occurred, but it became an epidemic because control measures were not sufficient to control it. So it may start that it is a sporadic disease, that it progresses into epidemic, then eventually becomes endemic. Hopefully not. Hopefully that will not the case. That be the case for monkeypox. But these are single or clusters of cases that they just randomly arise in specific areas. But again, knowing what we have discussed in the epidemiologic triad, nothing is at random. So now, in describing disease, the occurrence of disease through time, we usually plot an epidemic curve. Wherein, in the y-axis, we plot the number of cases, and in the x is the time. So usually, the time component or the interval of time used here is based on the incubation period of the disease, if the incubation period is known. So, for example, again, this was the previous diagram of COVID-19 cases. So we can see here that these are the number of cases, and these are the time intervals. So masyado lang siyang medyo malalayo lang siya because again we're 2 years in COVID. That's the main reason why. And we can see here how you can actually clearly see the progression of the disease. We can perhaps hypothesize that in these times wherein there are low cases, these are the times that we were implementing stricter lockdowns, or these are the times that the other novel strains or other novel variants of the virus has not other novel variants of the virus that are more infectious has not yet entered or has not been recognized in the country. Then perhaps the spikes are, of course, these are the times wherein the numbers are rising. So you can clearly see the progression of the disease, of an infectious disease or other infectious or otherwise actually, using an epidemic curve. And analysis of the epidemic curves gives us an insight for us to um, control certain diseases. Now, let's look at the epidemic curve on the different types of occurrence of disease. Yung mga demics natin. So if you can see here, and the sporadic, this one, on the left side, you can see here the mga paunti-unti yung number of cases. And they are few and very far apart. So the occurrence if you can see this, if you plot a disease occurrence and you see this, it may be indicative of sporadic occurrence of disease. Now, with regards to endemic naman, again, within an endemic disease, we would expect it to be present. Number of cases may fluctuate, but we expect it to be present in an endemic area. Hence, there are different number of cases as time progresses. But what's important here is that it's always there. Now, With regards to epidemics naman, there are two types of epidemics that you can actually use to describe epidemics or outbreaks. The first is the point source epidemic, wherein many animals or many units or many individuals or people are exposed to the source of the disease, be it an agent or a toxin or whatever, over a very short period of time, resulting in a very steep ascent branch to the epidemic curve. So this is the point source epidemic. So you can clearly see here that these cases on the right, as the time progressed, actually were perhaps exposed in a single area or in a single phenomenon over a very short period of time. Kasi, I can see that there is a steep ascent of the cases, then bigla lang din siyang bababa. You can clearly see that the transmission occurred over a short period of time. These cases were able to obtain the disease over a short period of time. So, perhaps an example of this is that where a foodborne outbreak, if you are to plot a foodborne outbreak, perhaps halimbawa associated sa isang fiesta sa barrio, nakikain sa isang bahay. So, if you plot cases, inevitably you perhaps would see an epidemic curve that is similar to this. In contrast, meron tayong tinatawag na propagating epidemic. This is one in which transmission occurs among individuals in the population, so that ascending branch ascends more gradually. So the exposure did not only this is the propagating epidemic. You can clearly see here that the number the cases indicate that it is fluctuating. When the epidemic curve looks like this, expect that transmission is occurring tao sa tao or individual to individual. Transmission or acquisition of the agent did not only occur in a very short period of time, in contrast to point source epidemic. So transmission is occurring person to person, animal to animal, group to group. Transmission is occurring and the disease is propagating, hence propagating epidemic. Now, we've gone through characterizing the disease with the individual. We've gone to characterizing the disease through time, its occurrence through time. Now, let's go to characterizing diseases through its geospatial or geospatial occurrence in a certain place. Again, this is just a spatial pattern of the disease. So this may be a consequence of environmental factors. So climate may be a factor, or what are the practices, management practices on that specific area. Maybe it's a lack of biosecurity, feeding practices, etc. That may have an effect on the spatial pattern of the disease. So mga traditional management practices could play a role. And with regards to this, you can actually use GIS or Geographic Information Systems to plot out the occurrence of disease such as this. Ito yung mga occurrence of ASF in June 2020 according to Bloom et al. So you can see here that by that time, the Philippines has already declared ASF in Luzon. You can see here on the dots. Now, you can use different types of maps actually in plotting out the occurrence of disease. So just for interest, this is John Snow, the father of epidemiology. So he was perhaps the most detailed usage of. He was the first one to have a detailed usage of that spot maps or spot maps in identifying the causes or identifying factors associated with disease. So he studied cholera in 1854 in London. Now, he used every single dot that you see here is a case. So with date at that time, they already knew that water intake or water might have played a role in the transmission of cholera. So what did he do? He marked the different water pumps on this part of London, and he analyzed that a number of cases were actually around pump A in Broad Street pump. So when they were able to hypothesize that it may be the pump A, they were able to address the matter, and cases actually have gone down. So this is a spot map, for example, of a spot or dot map. The usage of spot or dot map in epidemiology. You can also do, or you can also use choropleth maps. Choropleth maps, these are yung kulay-kulay na map. And of course, different color indicate different perhaps range. For example here, different ranges of days na wala ng cases or different types of zoning. So infected, buffer, surveillance, protected, or free zone. This is the situation of ASF in the Philippines on July 20. Last July 20. You can also use a combination of the two. So spot map na siya. Then the different colors indicate different intensity of occurrence of the disease. So this is COVID-19 in the US from the CDC. Now, for our last topic, let's go to the natural history of illnesses. So these are just some definition or mga definitional that I would like you to be aware of and I would like you to take note of. So of course, infection, I think I do not need to this to you. This is invasion of a living organism by a pathogenic agent. You have your infectivity, the ability of an agent to establish itself in a host. So basically, the percentage of affected. Pathogenicity is the ability of the agent to cause disease. So the percentage of the population that actually develop clinical syndromes, CX. Then virulence is the severity of disease caused by an agent to develop severe. The number of the percentage or the proportion of the population that actually develop severe disease severity. So pathogenicity between the two, within the realms of epidemiology, pathogenicity is the ability of the disease of the agent to cause disease. Virulence is the severity of the disease caused by the agent. So please be wary of the difference of the two. Exposure is interaction or contact between the agent and the host. So incubation period, I think, is I know you know this, is the period from acquiring the agent to the development of the clinical syndrome or clinical signs. Transmission forces movement of infection from one infected animal to another susceptible animal within an infected population. So spread is infection from an infected population or subpopulation to another susceptible population to subpopulation. So when we say transmission, it's just movement of infection within the same infected population. Pag sinabi naman nating spread, the infection is moving from one infected population to another uninfected population or another subpopulation of that. So carrier, these are animals that may not manifest disease but is capable of spreading the disease. So you have two types actually. You have your incubatory, so those who are infected disseminate the agent but are on the preclinical side of things. So ito yung mga na-infect na, nagkakalat ng agent, pero hindi pa nag-manifest yung disease. The second one is you have your convalescent, wherein infected na siya, nagkakalat siya, at saka after na siya nagkasakit. So it is apparently recovered from the disease, but it's still infected and is able to disseminate the disease. So for the disease to develop in an individual, so an individual, the animal or the person must be susceptible to the disease. And when exposure occurs, the animal progresses into the incubating or the preclinical side of things. So it may go into two directions. So the infected animal may manifest the disease, or it may go to subclinical. And within the clinical side of things, it may be diagnosed to have the disease. Or it may be that it is first subclinical, then developed to clinical, or it becomes clinical, then it is develops to a subclinical disease. Otherwise, when the animal, basically the point here is the animal got the disease or is manifesting or is manifesting the disease in a lower intensity, subclinical. It may be recovered, so it may develop immunity. It may be disabled, of course, as a result of the infection, or it might die. So you need to be wary of this disease progression, the natural history of illnesses in individuals, because in the study of epidemiology, these characteristics of specific diseases, kung paano sila, how do they go about within this route, is very important in the study of um, the epidemiology of certain diseases. So with regards to transmission, you have different types or modes of transmission of illnesses. So you have direct or indirect. So in the direct transmission, it could be horizontal. So direct contact with discharges, cannibalism could be a problem, or vertical transmission. So again, from parent to offspring. So transmission through egg, sperm, etc. Now, in the indirect transmission or spread, it could be an airborne transmission. So you have your droplet nuclei. If the transmitter or the airborne particle is less than 5 microns, equal to or less than 5 microns, it could be characterized as droplet nuclei, or it could be dust. So if it's more than 5 microns, it could be a vector-borne disease, so mechanical vectors, example of which is your sura. Mechanical vector is the tabanus, or a biological vector. For example, is your heartworm, for a heartworm or mosquito. Then for vehicle transmission, it could be fomites. So for example, vehicles or personnel. Food could also be, or animal products, or vehicle transmission to animal products. So foodborne illnesses in our public health are in our food hygiene. We have discussed this. Next, lastly, I think this is the second to the last slide. So we'll discuss herd immunity. So this is immunity in a group of individuals. So it may be innate, natural, or through vaccination. So of course, the main goal of having herd immunity is to slow the rate of transmission. So the ideal is 70 to 75 or even higher percentage of individuals to be immune to certain diseases. That's why we vaccinate. So of course, as this plot shows, when the number of susceptible individuals is very, very high, or almost everyone is susceptible to this specific disease, the spread is very, very fast. Whereas if there is herd immunity, we are able to put a barrier to the spread of disease, because there are a number of immune individuals. That's why COVID-19 vaccinations are very important in limiting the spread of the disease and limiting the number of people that die from the disease. So I hope you get the concept of herd immunity. So we are at the end of our first online lecture. So I hope that you have learned, learned a lot, I hope. And again, just to remind you that to read on the topics discussed here doon sa mga references na binigay ko, I hope you can read all of them and make your notes na din for your epidemiology notes na I will be requiring you to submit at the end of the semester. Then yeah, I hope I hope to see all of you soon, very, very soon. So thank you very much for your attention and have a good day.